we connect the resistances in series, we will get the maximum possible resistance or minimum possible current. ये note कर लीजिए. If you are given a number of resistances and you want to obtain maximum resistance in the circuit, how will you connect them? You will connect them in series combination. So series combination gives us maximum possible resistance. अगर गिवन रेजिस्टर्स हैं, हम चाहते हैं कि मिनिमम करंट फ्लो करे सर्किट में, so we will connect the resistances in series so that current is minimum because resistance is maximum. Yes, Tanya?
मैम सीरीज कॉम्बिनेशन नहीं हुआ था.
In which we can connect the resistances together, series combination and parallel combination. There are two combinations in which we can connect the resistances together. So, but before that, you write the definition of equivalent resistance. So, equivalent resistance is defined as single resistance. Equivalent resistance is defined as single resistance that would produce the same effect. Single resistance that would produce the same effect as is produced by a number of resistances together. Same effect as is produced by a number of resistances together. वो हो गया equivalent. So there are two types of combinations, series and parallel. Now when the resistors they are said to be connected in series, when they are connected end to end, you know this is a symbol of resistance. So when two resistors or three resistors they are connected end to end, one after the other, एक ही वायर में connected होते हैं, हम उनको series में कहते हैं. ठीक है? So you can write down the answer to this question. When the resistors are said to be connected in series, when they are connected one after the other, okay, end to end. When they are connected end to end, one after the other, then they are said to be connected in series. और parallel में कब बोलेंगे हम? Parallel में when they are connected between same 2 points. Suppose we are having 2 points A and B. Okay, this resistor R1 is also connected between these two points, and this R2 is also connected between these 2 points. So then they are said to be connected in parallel. For example, the room where you are sitting, वहाँ पे जो fan है, tube light है, all the appliances they are always connected in parallel combination. Because parallel में क्या होगा कि different currents will flow through different branches. अभी हम डिटेल में करेंगे इनको, ठीक है? So different currents will flow through different branches. So if one device turns faulty, others will not stop working. But if we connect them in series, if one device stops working, others will also stop working. सपोज आपका जो लाइट खराब हो गई है, आपका फैन भी बंद हो जाए, ठीक है? सो दैट विल बी वेरी वेरी अनकंफर्टेबल फॉर यू. सो टू अवॉइड दैट दे आर कनेक्टेड इन पैरेलल कॉम्बिनेशन. ठीक है, तो लिख लीजिए पैरेलल कॉम्बिनेशन में कब होंगे रेजिस्टर्स? व्हेन दे आर कनेक्टेड बिटवीन सेम 2 पॉइंट्स. Resistances are said to be connected in parallel if they are connected between same 2 points. And they are connected in series if they are connected end to end, one after the other. So this is the definition. Now we are going to do derivations. Now we will find equivalent resistance in series combination, equivalent resistance in parallel combination as well. ठीक है, तो अब हम सीरीज और पैरेलल कॉम्बिनेशन में इक्विवेलेंट रेजिस्टेंस कैलकुलेट करेंगे. ठीक है, सो which physical quantity remains the same here in series combination? Current remains the same. आप देख रहे हो कि करंट इसमें से भी उतना ही फ्लो करेगा, इसमें से भी उतना ही फ्लो करेगा. So which quantity remains the same in series combination? That is current. So current remains same. Please note it down. ये conceptual भी हो सकता है, ये MCQ की फॉर्म में भी क्वेश्चन आ सकता है. Which physical quantity remains same in series combination? So that is current. Current remains same. Same current flow करेगा. And suppose battery potential is D, then potential differences will be different. Potential differences will be different. So suppose V1 is the potential difference across R2 and R1, and V2 is potential difference across R2. ठीक है, तो टोटल पोटेंशियल डिफरेंस क्या होगा, V1 प्लस V2। करंट तो सेम है बट पोटेंशियल तो टोटल है ना बैटरी का, जितना भी उन दोनों के क्रॉस है। So let us use Ohm's law. You know Ohm's formula is V is equal to IR. So how will I write V1 using this? I should write V1 is equal to I1 R1 and V2 equal to I2 R2. But since current is same तो मैं I1 I2 नहीं करूँगी, उसको I लिखूँगी, ठीक है? So I will write V1 as I R1 and V2 as I R2. I write V1 as IR1 and V2 as IR2. ठीक है? And how will I write total potential difference? Total current into total resistance of series combination. RS क्या है? Equivalent resistance of series combination that we actually wanted to find. The total resistance into total current, that is total potential difference. Same way I have written V1 also, V2 also. If this step is not clear, you can ask. ओके, सो IRS इधर से I कॉमन ले लेते हैं, R1 प्लस R2, I gets cancelled and we get equivalent resistance in series combination is the sum of individual resistances. So in series we will simply add the resistances and this will be maximum possible value. ठीक है, if we connect the resistances in series तो ये हमें maximum possible resistance देगा, minimum possible current देगा। तो ये एक छोटा सा आर्टिकल है, आपको इस फॉर्म में आ सकता है। हो सकता है वो आपको 3 resistances दे दे तो एक और लगा देना साथ में, एक और टर्म आ जाएगी प्लस R3 आ जाएगा सेम वे। तो अगर 4 है तो 4 हो जाएंगे, 5 है तो 5 हो जाएंगे, लाइक दैट। ठीक है, so this is combination of resistances in series. Next is combination of resistances in parallel. Combination of resistances in parallel. Dakshita, yes.
मैम प्लीज ये दोबारा एक्सप्लेन कर दो।
कौन सा पॉइंट?
मैम ये जो आपने ये फॉर्मूला लिखा है रेजिस्टेंस को आपने प्लस किया जो,
एक मिनट बच्चे आप so see this, हमने ये इस तरह से I लिखा, ये आपको पता है V is equal to IR से हमने V1 को लिखा IR1, V2 को लिखा IR2, I कॉमन ले लिया, इधर ब्रैकेट में क्या आया R1 plus R2, this I gets cancelled on both sides, so you get RS is equal to R1 plus R2. Is that clear, Dakshita? Now I think these are very simple mathematical steps, easy mathematical steps. Clear है Dakshita? Clear? Okay, so next is parallel combination now. Parallel combination now we are going to do. Let us see how to calculate equivalent resistance when they are connected between same 2 points, when they are connected in parallel. So again we are taking two resistances R1 and R2 that have been connected in parallel between same 2 points, this point and this point. So this is R1 and this is R2 and they have been connected to a battery and a key. So again current starts flowing, but you will see ये current आगे 2 parts में divide हो रहा है. Current can't be the same here. Current is dividing into 2 parts here. Suppose here current is I1, here current is I2. And again total current I बाहर आएगा. जितना current enter करना चाहिए उतना ही leaving भी होना चाहिए. So always you have to divide the current in such a way that current entering is equal to current leaving. ठीक है? Current entering should be equal to current leaving also, right? So is the circuit clear to you? ये I current जो आ रहा है that is dividing into 2 parts I1 and I2, so current is not same here. What is same then? Potential difference is same. ठीक है, क्योंकि देखिए V is equal to IR. There are 2 different resistances. ठीक है, जिसका रेजिस्टेंस कम है उसमें से मोर करंट विल फ्लो एंड जिसका रेजिस्टेंस ज्यादा है उसमें से लेस करंट विल फ्लो, बट द प्रोडक्ट विल रिमेन कांस्टेंट। एक चीज ज्यादा है एक चीज कम है तो ये कांस्टेंट हो जाएगा, तो आपका पोटेंशियल डिफरेंस सेम रहेगा। इन दोनों के अक्रॉस भी उतना ही पोटेंशियल डिफरेंस है जितना इस बैटरी का है, so potential difference will remain the same. So which physical quantity remains the same in parallel combination? Note it down. Potential difference remains the same. So in parallel combination, potential difference remains the same. Okay, in parallel combination, potential difference always remains the same, but total current is the sum of two currents. I is equal to I1 plus I. अब यहाँ पे करंट जो है उसका सम उन दोनों के इक्वल। So again we use Ohm's law. I is equal to V over R. From V is equal to IR, we can write I is equal to V over R. So how I can write I1 now? I1 में कैसे लिखूंगी? V1 over R1 और I2 V2 over R2. But क्योंकि V सेम है, तो I won't write V1 V2. I'll write V over R1 and V over R2. ठीक है? So I'll simply write I1 as V over R1 and I2 as V over R2. Total current is total potential difference over equivalent resistance of parallel combination. So what is RP here? Equivalent resistance of parallel combination that we actually wanted to find. तो note कर लो यहाँ पे RP क्या है? That is equivalent resistance of parallel combination. If this step is not clear, you can ask. Simply Ohm's formula use करके ही हमने I1 I2 को लिखा है और I को लिखा है total करंट। All right. So let us take V common from the right hand side. In the bracket we are left with 1 over R1 plus 1 over R2. And how can I write V over RP? I can write V into 1 over RP. I can write V over RP as V into 1 over RP. So V gets cancelled on both sides. V gets cancelled on both sides. And finally I am left with the formula 1 over RP is 1 over R1 plus 1 over R2. So this is how we calculate the equivalent resistance in parallel combination. We'll add the reciprocals of individual resistances to get the reciprocal of equivalent resistance. So learn this. Okay? तो यहाँ पे लिख लीजिए, कमेंट लिख लीजिए एंड में. So the reciprocal of equivalent resistance. So the reciprocal 1 over मतलब reciprocal. So the reciprocal of equivalent resistance is the sum of reciprocals of individual resistances. So the reciprocal of total resistance, equivalent resistance, is the sum of reciprocals of individual resistances. This is the formula. अगर तीन होते तो हम क्या करते? ठीक है, अगर तीन रेजिस्टेंस पैरेलल में होते तो we would have written 1 over R is 1 over R1 plus 1 over R2 plus 1 over R3. तो एक और टर्म ऐड हो जाती है. ठीक है, एक और टर्म यहाँ पे ऐड हो जाती है. 1 over R is 1 over R1 plus 1 over R2 plus 1 over R3. एक और टर्म यहाँ पे ऐड हो जाती है. And this would give us minimum resistance possible. चलिए, चलो क्लियर है ये. So if you are given a number of resistances and you want to calculate minimum possible resistance, so what will you do? You will connect them in what? You will connect them in parallel combination. तो maximum current देगा ये आपको. ठीक है, this will give you maximum current or minimum resistance. Is that clear? All right, students. Fine. चलिए, इसका मतलब RS is always greater than RP. नोट कर लीजिए. Series resistance is always greater than parallel resistance. RS greater than RP. Note it down. Series resistance is always greater than parallel resistance. ठीक है, चलिए. So now I'm going to share a video with you. I'm going to share a video जहाँ पे अब तक का हमारा थोड़ा रिवाइज हो जाए, right? So that will be quite helpful to you. I'll send the link also today to you. You can see. Here with term charge, two types of charge, methods of charging, and universal law of electrostatics. In this video, we'll discuss three macroscopic quantities: potential difference, current, and resistance. So let's get started. To understand the potential at a point, assume a +1 coulomb of charge lying at infinity. We want to bring it up to point P in the vicinity of a source charge Q. As we bring the charge closer, repulsion happens, and if we continue bringing the +1 coulomb charge closer, work has to be done. This work done per unit charge is termed potential. Potential difference between 2 points is similarly work done to bring a unit positive charge from one point to another point. In layman language, potential difference is called voltage and its unit is volts. When a vessel is filled with water, its level raises. Same way, when an object is given charge, its potential raises. So, positive terminal of a battery has higher potential and negative terminal of a battery has a lower potential. Since current always flows from a region of higher potential to that of lower potential, it will flow always in a circuit from positive to negative terminal of cell or battery. The device that can perform this function is called a battery.
Imagine you have two beakers filled with equal amounts of water, and they are both connected to each other by a pipe at the bottom. If you observe the two beakers for a few seconds, do you think the water will flow from one beaker to another? No, you will see that the water in both beakers is as is, and there is no flow from any beaker to the other. Now let me give you a task. Without changing the amount of water in any of the beakers, can you make water flow from beaker 2 to beaker 1? Understand my question again. You need to make water flow from beaker 2 to beaker 1. But you're not allowed to change the amount of water in any of the beakers. So you can't add or remove the water from any beaker. How will you do it? It's easy. One of the things you could do is raise the height at which the second beaker is kept. Once it's raised at a height, the water will flow from beaker 2 to beaker 1. What exactly happened here? What was the factor that made water flow? In simple terms, the factor was height. Yes, you can talk about gravity or pressure difference. But in layman terms, it is the height difference that causes the water to flow from the second beaker to the first. In an exactly similar way, for electricity to flow, there has to be some factor. We'll come to that factor soon, don't worry. So if we just have a copper wire, do you think electricity will flow through it? Clearly not, because there's nothing that's triggering it. There's no factor triggering it. So what is the factor that triggers the flow of electricity? It's called the potential difference.
So this video provides a similarity between potential difference and water flow. We can also compare potential difference to heat flow. When a hotter object is brought in contact with a colder one, heat flows from body at a higher temperature to the body at a lower temperature till temperature becomes the same. Same way, when we have 2 points of a wire at different potentials, current starts flowing. Let us now see how charges flow inside a wire and how current is produced through an activity. In this activity,
we have a pipe containing some steel balls, and there is no space for an extra ball. If we want an extra ball to enter the pipe, one ball must be removed from the other end. Same way, in a wire, there are billions of electrons. And if we want to make an electron,
if you have a wire, we have already discussed this. If you have a wire, as such, no current is flowing through it because there is no space for electrons to move. Otherwise, they are packed. Okay, but when a battery is connected, it pushes the electron through one end and it starts going out through the other end. So this way the flow of electrons starts and current starts flowing. So battery is that driving force that causes the current to flow in a circuit. ठीक है, तो इसका बाकी का पार्ट जो है हम कल देख लेंगे. We have 2-3 minutes, so I can again share. देख लीजिए थोड़ा सा.
an extra charge inside a wire and also remove the charge to maintain current flow. Now I'll show a simple electric circuit. Some components are a switch or key, LED or bulb, 2 carbon resistors, connecting wires, battery and bulb.
ये दिखाया हुआ है मैंने आपको.
Across the
This
end.
is Ohm's
If we
experiment.
connect one cell in the circuit, suppose 1 ampere current flows. On connecting 2 cells in series in the battery, suppose the current is doubled. On connecting 3 cells, current will be tripled definitely, and so on. So in this case, current is directly proportional to potential difference, not potential difference proportional to current. So we can say I proportional to V and mathematically V proportional to I, and the constant of proportionality is R, the resistance of wire or conductor. Ohm's formula V is equal to IR can be learned through the triangle as shown. VI graph for an ohmic conductor like metal that obeys Ohm's law will be a straight line. The slope of VI graph is resistance, but the slope of IV graph is reciprocal of resistance, that is conductance. I have a task for you. In the previous slide, you have to tell me the readings of emitter and voltmeter.
अब सीरीज पैरेलल
If we
देखिए.
connect 2 bulbs of power 100 watt each in parallel, the resistance R is equal to V square by 3 will be equal to 484 ohm each. When they are connected in parallel, resistance will decrease and glow will be more. But when they are connected in series, resistance will increase and glow will be less.
ठीक है, तो ये है. तो आपने देखा when these two bulbs were connected in parallel, they were glowing brightly. But when they are connected in series, तो उनका potential share हो गया. बैटरी वोल्टेज जो थी वो कंज्यूम दोनों कर रहे थे, तो उससे उनका ग्लो, उनकी ब्राइटनेस कम हो गई पहले से. ठीक है. So this is the difference between series and parallel combination. Is that clear?